Hello YouTube. Today we're going to be looking at this HP Victus. Now, I don't believe this thing powers on. I think it's a no power unit. I have looked at it before, quite a long time ago. It's been in the cupboard for a long time, and I think it's finally time to see if we can make it work. Now, this laptop is a no power laptop, so if I plug the charger in, I don't think anything happens. No response to the power button, just completely dead. I don't think we get any LEDs. No charge LED either, which surprises me. As I say, it's been quite a while since I last worked on this laptop, so I don't remember exactly what's going on, the exact symptoms. I thought I would get a charge LED. So we're going to check, make sure the 19 volt rail is present and that sort of thing, and we can get on to diagnosing it, and I'll talk you through what I think is wrong with the laptop as we get further into the video. So let's put the charger back in and see if we can't identify the 19 volt rail. So as usual, let's go under the microscope. I'm going to look for, actually let's just double check that we get voltage in from the charger, because I've not checked that this charger's plugged in properly. So let's do that and switch the multimeter to DC voltage. Take a look, and 19.5 volts. Okay, and now we're going to want to try and identify the main 19 volt rail, which is going to come after a couple of MOSFETs. So the power will come in through the DC jack, go through a couple of MOSFETs, and if the charge circuit's working correctly, we'll get 19 volts out to power all of the other buck circuits on the board. So if I just pan over here, we have a typical regulator configuration. So we'll have probably 19 volts going in there. This regulator will drop that down to, I don't know, 5 volts or 3.3 volts or something, and it'll shoot out of this coil here. So, do we have 19 volts going in? Yeah, okay, 19 volts. Still no charge LED. Now, if I remember correctly, this laptop had a short on 3VLP. Well, sort of. So, there's a regulator somewhere over here, tiny bit of flux on it. I think this is the one that is our problem. And if I remember correctly, it gets hot. So, if I put a bit, yeah, there we go. See how that's burning up with alcohol? That's evaporating almost instantly. And we should be able to see that on the thermal camera as well. If I point in this direction, should be able to see that glowing in that area. If you watched the Acer EC Vertianal programming video I did recently, you'll know that this regulator getting hot could be the result of a short on the LDO output of this regulator. So if I measure the main, the resistance to ground on the main inductor, I don't think it's going to be short. Let's get a red probe to ground. Oh, it is short. Okay. My memory has failed me. And what about the LDO output? That's 98 ohms. Crazy, I didn't think the main coil was short. Okay. This might be simpler than I thought then. Maybe I'm misremembering. But yeah, we know we've got a short circuit. And I think, if I remember correctly, this is a 3 volt output regulator, so it will power like the EC chip and the PCH and that sort of thing. And I think the short circuit is a bad one. I think the PCH chipset, which is part of the CPU on this laptop, is dead, and that's why this coil is short to ground. So what I'll do is I'll take the board out of the chassis, and we can inject some power here and see what gets hot. Because this regulator getting hot is probably not the problem. The problem is probably the short circuit on the output. Yeah, no battery screws. That's nice. Now, I think my memory is correct. I think the CPU is bad, and one of the reasons I'm a bit more confident now is because I've already rubbed the thermal compound off the PCH section of the CPU. So that suggests that there could be a hot spot there. Now we can check some other things before we inject some voltage, see if we can deduce that it definitely is the PCH without using the bench power supply. We should have some power rails up here for the CPU, and I think there's a 1V8. And for example, if we have a short on our 3V and our 1V8, they both connect to the PCH. You can probably assume that the PCH is the factor that's leading to both of those short circuits. So if we have multiple shorts all pointing towards the PCH, we can be pretty confident without injecting power from the bench supply, but we'll do both. We'll do both. So let's check. Let's show you these power rails up here. And we're going to have some coils. A few of them will be for CPU core voltage, maybe CPU graphics voltage, and then somewhere around here we have a, I don't know, a 1V8 maybe, some kind of other CPU power. Let's check CPU core. 20 ohms. 20 ohms. So those 4 coils, these ones are all 20 ohms. They'll be connected to one another. What about this? I don't know if this is going to be related. That's 10 ohms. You can see power runs out of that coil there, down this fat looking trace into the CPU. So that could be a short circuit. We've got some other CPU stuff going out of this little voltage switch here as well. So one of these sides, the switch will be input. You can see 1, 2, 3, 4 pins all tied together on the input, and then I presume that'll be the output running down this big trace here under the CPU. What do we get here? Hey, yeah, 0.0 ohms. That's also short. So we have low resistance up here. We have 0 ohms here. We have 0 ohms on the 3.3 volt. And they all point to the CPU PCH being short. This is a 13th gen Intel Core i5. So it's quite a new system. I've not tried replacing one of these before, but yeah, I think today that's what we're going to do. Let's just inject some power and see if we can get the PCH lighting up on the thermal camera, see if we can see any hot spots. Just switching my probes from my multimeter straight into my bench power supply. We're going to put 3 volts at 3 amps into the 3 volt rail. And it immediately draws 3 amps. If we grab the thermal camera again, you can see, hopefully see, PCH is getting hot. And we can use the alcohol trick to double confirm that it's not a reflection or the thermal camera playing tricks on me. So let's drop some alcohol on there and inject voltage. And you can see it starts to evaporate on that corner almost immediately. So yeah, this thing needs a new PCH. Unfortunately, it's attached to the CPU. So the only way to fix this is with a CPU replacement. And CPUs are expensive, so not that many people will want to replace this CPU, especially being 13th gen. On AliExpress, they're definitely in excess of £100. It's a big risk to put into a system, especially when you don't know what led to the failure in the first place. But we're going to try and do it, and we're going to try and do it cheaply. I feel like I'm cheating a bit here, but I have another CPU. This one is a bit more powerful, so this is a Core i7-13620H, replacing the Core i5. But I don't know if this one works. This came from a donor board. A donor board with no power, a donor board that I never tested properly, and so who knows what's going to happen when I fit this CPU to this board. If it doesn't work, I also have another donor board. Where did I put it? Here we go. This is a Lenovo donor board. I had some USB-C problems, but I know this CPU works. So if that one doesn't, then we can rip this CPU off, reball it, and try this one on this board. There are still some other things that we need to consider. Now, there is firmware within the BIOS that links each PCH to the BIOS chip. It's called the ME region. So when we replace the CPU, we're going to need to reprogram the ME region, which is, it's not so difficult. The next thing we need to consider is on a PCH, there is also something called boot guard, which is basically within the PCH, there are one-time programmable fuses. So on first boot, these fuses blow to match some settings determined by the manufacturer. What that means is we might find that the fuses on this PCH are blown to a different configuration than this PCH, and if it detects that it's not correct, the system won't boot. So who knows what's going to happen. I've not tried doing a 13th gen CPU swap, I've not tried doing a 13th gen CPU upgrade, and I've not spent too much time messing around with boot guard. But someone's got to try it, so let's get this board prepped for rework and put the CPU on it, see what happens. Right, so it doesn't look like there's any epoxy left. I guess I removed that edge bonding. There should be some red epoxy, like around the GPU. But for some reason, it looks like I've already removed that. I'm the only person that's worked on this system. So maybe at some point I thought, hey, let's do a CPU, and then changed my mind. I don't know why. But yeah, okay. So that's all ready to go. The only other thing we need to remove, well, there's a couple things we need to remove before we get on the rework station. Let's, is this soldered? Is this shield soldered? This shield's soldered, so that you can't really remove. And on the back of the board, any stickers. And of course, we have the brackets that hold the heatsink onto the board, these big metal things. They're stuck down with adhesive. We're going to want to lift that up and try and remove these cleanly before we rework it, because when this gets hot on the rework station, these brackets will just fall off because the adhesive loosens. So we want to remove that before we go on to rework the board. I'm going to do that with a bit of heat from the heat gun and, I don't know, a pry tool, something like that to get under here as I heat up. And hopefully we can remove it without damaging any components. Just using the heat to soften the adhesive. So up my temperature a little bit, speed things up. I'm going to do our best not to bend these, but the adhesive is quite strong. One down. And the other one. We've left a bit of adhesive on the board. I'm just going to try and pick that off as best I can, just so it doesn't melt and go brown on the back of the board when we're removing the CPU. Okay, I think we're ready. I'm going to go put this on the rework station. I recently got a new rework station. It's a Ursa IRPL 650. Very fancy, nice machine. I haven't fully dialed it in yet, but we're going to try and remove the CPU on that station and see how we get on. I'll move my cameras over to that station, get set up, and we can continue the video over there. Okay, there we go. We have the CPU removed. Now, as I say, this rework station is new to me, and I'm not sure if it'll translate in the footage very well, but I had a bit of trouble removing the CPU. It removed okay, but I raised it up too much, and it dropped back onto the PCB. But, you know, it removed okay. There's no pulled pads. Hopefully I've not messed up any passives around the CPU area by dropping a hot chip onto it. But we'll see. Now here's the CPU. And yeah, it looks okay. Let's get you under the microscope. I want to show you something about these Intel CPUs that might catch out a few people. They arrive pre-bent. So that curve across the plane of the CPU is not due to my profile. It's not due to me removing it. This is just how these chips are. So if you ever buy one of these CPUs from AliExpress and it arrives with a curve in it, it's meant to be like that. Well, I say it's meant to be like that. It's never ideal. But what happens is when you heat these up, they expand in such a way that they tend to correct themselves as they solder. So I've not found it to be too much of a problem when you're fitting replacement chips. Just something to bear in mind if you're ever reworking Intel CPUs, especially the longer ones with the PCH. They sort of have non-uniform thermal mass, but they do flex out as you heat them up. So yeah, nothing to worry about too much, or at least usually. So there's our CPU, and let's have a look at the board that accompanies it. Take a look at how we did. Put a bit of flux under there, just as I lifted it off. Let's have a look at the passes around the outside first, because, as I say, I dropped the CPU on them, but they look like they were probably no stuff before. Doesn't look like I've messed anything up too much. Yeah. No, we got away with it. We got lucky there. Even though we dropped the CPU, it didn't knock any components somehow. So it's good. Now there's already flux under it, so it's gonna do the usual. I'm gonna roll some leaded solder over the lead free, and then we're gonna wick up the pads, and we can get it back on the rework station to fit the replacement CPU. And hopefully the replacement CPU I've got, hopefully the first one, is gonna work, but who knows. Looks pretty good on the first pass. Nothing obviously sticking up. It's easier to feel around if you're not wearing gloves. There looks to be a couple of high spots down in this corner. So I'm just gonna go over that area. You see a couple balls. Bit of residual solder on them still. That's good enough for me. Let's add some flux. Should be enough. Maybe a little bit more required. Well, that looks okay. We can take our new CPU and we can put it on. Now, I do have optical alignment on the new rework station, but this has a silk screen around it, and so we're going to know when it's in the right place. We don't need split vision or anything fancy to install a CPU like this. It can be nice to have, but seems okay. Okay, I'm getting pretty excited now. I'm very interested to see if this random donor CPU works, or if I'm going to run into any sorts of problems. You know what I didn't do? I didn't check to see if our shorts had lifted. So let's just quickly do that before I fit this new CPU. It's always a good idea. So got down at 3 volts, 370 ohms. Up at this one, which is probably 1V8, 280 ohms, 512 ohms. Okay, and this one over here, 25k. So it looks like all of our shorts resolved. Yeah, one thing left to do, put this CPU on. Then we can plug it in and see if it turns on. Okay, we're back, and here is the board with its new CPU soldered. Now I think the soldering went okay, so let's have a look. Oh. So you can see now the part number of the CPU down here is SRMJO, which is the i7 13620. And if I raise my scope and turn up the brightness, we should be able to, wrong way, should be able to take a look at the balls underneath the chip. And they look happy. You can see the, what I was talking about earlier, the CPU doesn't seem to be warped now it's soldered to the board. So, that's good. Right. Let's get you in some kind of focus. Lower the brightness a little. There we go. And we can check first to see if our shorts are gone. So, on the, what I presumed was 3.3, we have 360 ohms, which is good. We have 160 ohms, which I think is fine. And lastly, this one, which I think was 10 ohms before, is 10 ohms now. So maybe this is normal. I don't have a schematic or board view for this. I mean, I've not looked, but there wasn't one available when I first looked at this machine a year ago. So I don't know. I guess there's probably not a board view or schematic available. I might have a look later if I can't get this working, but for now, we're just going off what we know. That was 10 ohms before, it's 10 ohms now. Probably meant to be 10 ohms. So, we've resolved 2 short circuits. The CPU is on there. I wonder what happens if we plug it in. I don't know if this board is going to auto start. Some Intel boards will turn on as soon as you plug in the charger. Some won't. So, you know what, if I get my thermal camera out, we can plug it in with a thermal camera above the board and see if anything's getting hot. Hopefully this works. But I really don't trust this CPU. I think the chances are low. Are we still getting a hotspot on that regulator? Or is that above it? Is that up here now? Looks like we might have another short circuit. Nothing else is getting hot. Just bring you over to the area that I think was getting hot. I think somewhere around here, which is this regulator again. So we can measure the LDO, which shows up on this jumper here. That was about 100 ohms before, now it's 300, which is okay. We can measure here, which we just measured at 360. And it's still 360, so nothing's died. 396, 37.47. Strange. What if I drop alcohol in this area? See if anything gets hot. Let's plug it back in. Oh, it's this regulator again. That's strange. No short circuits, but this regulator is still getting hot. At least no short circuits that we see. What if I drop some alcohol on the chipset? Plug it in. Nothing seems to be getting hot on the chipset right away, which is, I guess, good, but we've still got something going on with that regulator. So, what I think I'm going to do is, we have this LDO pin here. I think I'm going to inject voltage to the LDO pin and see if it draws current. And if it doesn't, I'm going to inject voltage onto the main output rail and see if that draws current. Maybe we've got a cascade failure where multiple things across the board have failed. Maybe it's something to do with a new CPU. I do not know yet. Okay, we're back onto 3 volts, 3 amps. And chuck it in there. It's drawing 2.3 amps, which is a little bit lower this time. And there's maybe a small heat spot occurring just around the left side of the CPU, but the CPU itself is seemingly okay. Yeah, if I remove the probe, that area there cools down again. So what's going on under the board in that area? Whoa, does that diode have a hole in it? I think that diode has a hole in it. That diode is burnt right out. Okay. Just going to put my probes back in my multimeter. Sure. Okay. This diode, 57 ohms one way, 62 ohms the other, and resistance to ground. It's 0.5k and 0.5k. Okay, so it's not short, but it does have a hole in it. I wonder if fixing that or replacing that diode is gonna relieve the hotspot on the regulator. I'm not really sure, but we're gonna have to try. So I'm gonna find something that looks vaguely suitable. As I said, I don't have the schematic, so the value of the diode is gonna be basically guesswork. But we'll remove this, put something else in its place, and we can see if anything changes. Found this diode here. Looks a little bit on the big side, but might be able to make it work. Just about. If I can keep hold of it. Where'd that go? Add way too much flux. I mean, it's not pretty, but it might work. As I say, no idea if that diode's the correct value, but we can plug it in again and see what happens. Right, thermal camera. Our regulator down there no longer seems to be getting hot. Okay. What voltages do we have? We have 3.3 on the 3.3 reg. We have 3 volts on its LDO output, which is good. Do we have anything up here? So the 10 ohm coil, unknown voltage, is currently 0 volts. And we have 3.3 volts to the BIOS chip. So, let's have a look. This might be working, but it might not auto start. So, there's a power button jumper down here. Just make sure that that has 3 volts on it. And it's got 2.2, which is interesting. May still function. Who knows? So let's short that out, and we can see if anything gets warmer. Is that a no? Nothing seems to have come to life. We do have a white LED on the DC jack now, which we didn't before, which I guess is good news. Did we gain any voltages when I hit that button? No, that coil's still 0. We have 5 volts down here. We have 1V8 down here. We have 5 volts DDR maybe. So this could be halfway turning on. Seems to have most of its rails. I presume nothing on GPU. Oh, we've got 1V8 up here. No GPU core. Therefore, no GPU memory. PCH might be getting a little warm. Yeah, there's a couple of spots on the PCH that are getting a little warm, which might be bad news. This CPU PCH combo might be bad. Should we check our diode? So, one side of this diode, we get 2.9 volts, and the other side, we get 3.2. I wonder what DC5 does. But it's allowing voltage to pass, it's not dropping it too much. Maybe it's something to do with RTC, or some clock power line. Wait a minute. Maybe I should have a look over this. Because that diode there looks like it's got a hole in it as well. 2.9 one side, and 3.2 the other. Okay, let's change back to resistance and see if that diode's short. 65 ohms one way, 61 the other. Yep, that diode's cooked as well. DN1. Okay, we put another oversized diode on, and let's go back and plug it back in. We go back to voltage a second, and I'm just going to measure to see if those power supplies are coming up straight away. Yeah, we've got 5 volts there, 3V3, 1V8. Our power button signal is still a little bit low. I'd expect that to be 3 volts. That's kind of interesting. But because all these rails are coming up, it does suggest that the board's trying to auto start. And maybe failing to do so? Yeah, we've got no voltage on CPU core. What about up at our regulator here? We have in 1V05, out 1V05. And the PCH is getting a little bit warm. I don't know, guys. I'm not sure I trust this CPU. This PCH. It might be fine, but it might also be the cause of our no power. As I said before, I didn't trust this CPU, PCH, at all. So, it might be time to fit the other one. I'm going to have a quick look over the back of the board and the front of the board. Make sure I've inspected it fully and thoroughly. Just make sure I'm missing nothing obvious before we make any further decisions. Okay, so interesting development. I can't seem to get a connection from that jumper to the keyboard connector, and the power button is on the keyboard connector on this. So for some reason that signal is not connected over here. And should be. Maybe there's a resistor that's meant to be populated to allow the debug power button to work or something like that. But let's just recheck for voltage on the keyboard connector and see if we can determine which one is the power button signal. 3.2, 3.2, 3.2. You know what? There's a whole lot of 3.2. It's just going to be easier if I put the board quickly back in the chassis, hit the power button and see if anything changes. Okay, well the power LED doesn't come up. And the CPU is getting no hotter than before. I think our random CPU is dead. I don't see anything else on the board that could be damaged. It does have a small hotspot, which is kind of suspicious. I think it's time to start stripping down our other board with the known good CPU. I mean, we still haven't reprogrammed the ME region, but that shouldn't cause no power. So I really do suspect this this CPU was a waste of time. Yeah. Well, that sucks. Thank you for watching. I hope you enjoyed watching me fail to fix this HP. And I'll see you next time, where we take the CPU off a Lenovo board, put it on this, and try again. Goodbye.